Surya, just give you a brief intro about yourself.
Okay, sir. Sir, I am Surya Pratap. I am from Vijayawada, a city in Andhra Pradesh. I have done my Bachelor's of Technology in Mechanical Engineering from IIT Kanchipuram, Chennai, sir. I completed my graduation in the year 2019. From then, I have joined in M.Tech in Thermal Engineering at IIT Madras. I have completed my master's course in the year 2021, sir. And I have published an article in a PVSC, sir, Photovoltaic Specialist Conference. In the year 2021, I have joined in Steel Authority of India Limited, sir. Currently, I have been posted at Rourkela Steel Plant, and I am working at Raw Materials Handling Plant, sir. My father is a school teacher, sir. My hobbies are cooking and listening to music, sir. Sir?
Okay. Yes, sir. So just tell me, what's your branch in M.Tech?
In Thermal Engineering, sir.
Thermal Engineering. Okay. So just tell me, if I am just assuming a nozzle and assuming a flow of supersonic.
Sir.
I am just assuming a nozzle and the
Yes,
flow in the nozzle is a supersonic. I am just assuming a converging passage where the flow is a supersonic. So how it's work? What are the changes in comes in the different properties, just like a pressure, temperature, Mach number?
Yes, sir. For a supersonic flow in converging nozzle, it will the speed will decrease, sir, and the pressure will increase. We need a diverging nozzle for the Mach number to increase in case of supersonic flows, as similar to like a rocket exhaust.
Can you say this? Which equation you are just applying here?
Sir, which
Equation you are applying here? By which equation you can say that the velocity is going to be decreased in the converging passage?
Sorry, sir, I could not able to recollect it.
Okay. Next question. Which theory of failure is applicable for the brittle material?
It's a Rankine theory, sir.
Why only Rankine theory is applicable to the brittle material?
Remaining, we can use other theories also, sir, like distortion energy theory. But
distortion energy theory can be used for the brittle material.
Yes, sir, but it won't give that much accurate, sir, as compared to Rankine theory for brittle materials.
Are you confirmed, Surya?
Sorry, sir, I cannot confirm it.
Are you know about the Lehm's equation in a thick cell? Lehm's equation in a thick cell.
Thick cell?
Yeah, thick cylinder.
Thick cylinder. No, sir.
You don't know about it?
No, sir.
Okay. I know about the siphon.
Yes, sir.
What is a siphon actually?
Sir, siphon, we use siphon to deliver the fluid from a when the passage, the height of the passage is more than that of the level of liquid surface, sir. We use the principle we use the vapor pressure to suck the liquid from the height of the datum, sir.
Vapor pressure to the liquid. I don't get it. I can understand about that. The flow should be, the height should be above.
Yes, sir. Can I draw and show you?
Try and just explain clearly, so I can understand about that.
Yes, sir. Sorry, it looks like this, sir.
First of all, just जो blur कर रखा है ना आपने आसपास का, उसको blur मत करो. कोई दिक्कत नहीं, कैसा भी हो. क्योंकि क्या ना वो पेपर दिखता नहीं है क्लियरली.
Yes, sir.
जो वीडियो का ऑप्शन आ रहा है स्टॉप वीडियो, इन द स्टॉप वीडियो जस्ट There is a one icon also in a stop video where in the left hand side, yeah, now it's okay.
Now is it okay, sir?
Yeah.
This one, sir.
This
Here,
is called a cipher.
yes, sir. With this
So what are the conditions for the cipher?
siphon, it's like if the you mean the height of the water level is less than that of the pipes, then also it can suck the liquid inside it, sir, with the by the concept of vapor pressure. Then we can deliver we can get delivery of water here, sir.
Vapor pressure concept area. You're using the vapor pressure concept here.
Sir, actually
It's a vapor pressure. Are you confirm?
Actually, sir, here the
What do you mean by vapor pressure? Just tell me.
vapor pressure, it is a pressure exerted by the vapor of the fluid, sir.
So here the vapor pressure will work. Actually, are you just providing some heat here?
Not heat, sir.
There is
The
a evaporation
corresponding
taking place
pressure
here.
is the corresponding saturated pressure is less than that of compared to the pressure supplied by the the pressure required to lift the water from the container, sir.
So it is due to the vapor pressure.
Means not due to the vapor pressure, sir. There vacuum will form, sir. Like
Say that now, vacuum, not the vapor.
vacuum.
So both things are very, very different to each other.
Yes,
Vacuum
sir.
is another thing, the pressure lower than the atmospheric. Vapor pressure is the pressure hit by the vapor.
Yes,
So
sir.
both are a different thing. So don't say the vapor pressure.
Okay.
So how much heat, how much amount of height we can provide to the siphon? Can you calculate that for a water?
Sir, it's around like it can come up to 10.33 meters of water column, sir.
Can be 10.3.
Sir,
So we can raise the level up to the 10.3 of meter for summit.
means, sir, if we don't consider the frictional losses and the losses at bends, then we can.
We can get up to 10.3 meter.
Yes, sir. It is the. Yes, sir. It is. We can take up the atmosphere.
What is the vapor pressure of water?
Sorry, I didn't remember the numbers.
Okay. Can you just tell me how the variation of a shear stress occurs in the pipe in the case of a laminar flow or the turbulent flow?
Yes, sir. Sir, if the velocity profile is linear, then the variation of shear stress profile will be like straight line, sir.
In which case, laminar or turbulent?
For laminar flow, sir.
In case of turbulent?
Turbulent. Turbulent, I don't have idea, sir. We use some Boson, like a Bosonisk hypothesis for that, sir. And then the parental mixing length for the calculation.
Okay, Surya, if you will select it in a DRDO, so in which section you want to work?
Sir,
Have you studied about the DRDO?
Sir,
The DRDO works in which departments or which deals with the which products. So where you want to do the work?
Sir, I want to work on missile systems, sir.
Okay. So which type of missiles? What are the types of missiles?
Sir, according to the range we can the is like distinguish like short range missile, medium range missile, intermediate range ballistic missile, and intercontinental ballistic missile, sir. With the type of propulsion, we can on the base of propulsion we can classify as like cruise missile and ballistic missile, sir.
What is the difference between cruise and ballistic?
Sir, excuse me, sir. Sir, in case of cruise missile, we need we propel the engine till it hits the target, sir. It need to be cruised from the starting point to the end point, sir, till it hits the target. But in the case of ballistic missile, we propel the engine up to a certain point of the trajectory, sir. From thereafter, it follows the ballistic trajectory.
You can just tell me how the missiles will work?
Yes, sir. For the case of ballistic missiles, we use rocket engines, sir. For the case of cruise missiles, we use scramjet engines, sir. For in case of scramjet engines, the critical parts are like navigation technology, navigation system, and propulsion system, wings and aerodynamic features like wings and fins, which used to guide the missiles, sir.
Okay, can you just tell me how the missile will take that turn?
Yes, sir.
Initially, they are just going to move upward direction. After
Yes,
this, they take that turn just like a left, right, and the whatever. So
yes,
how
sir.
they are just take that turn? What are the mechanisms behind it?
Sir, the mechanism behind it is like we use aerodynamic things like wings and fins, sir. With the use of wings and fins of the missiles, sir. With the use of them, we turn the missiles.
Wings are not a movable part of the missile, are you know? That is moving. Wings are or a fixed part.
That I don't know exactly, sir.
Okay. So Surya, overall, I will just give you the feedback. After that, Lokesh sir will interact with you. Overall, you are a good, and a little bit some confusing points you just see there. Now, try to revise the things. One thing I just told you, read it the thick cell very carefully. They are just asking. And the difference between the ballistic and the cruise missile, how they are just works, how they exchange the turn. Okay. So these are the questions which are they are just asking in the previous interview, just like 2 or 3 days before. So I will just give you some hints about the question.
Okay, sir.
Whatever the question I'm just asking to you, they all are asking by the DRDO interview panels.
Okay, sir.
So try to revise the things.
Okay, sir.
Now the sir will interact with you, and I will just call you at the tomorrow evening. Just give me the feedback about your mock also, about your final interview.
Okay,
And you have a good confidence, so I think you will do the well. And one thing, just prepare the MTech and as well as just define why you want to join a DIDO when you are also in a good position in a sale. So that will ask by the sir also.
Yes, sir. Okay, sir.
Sir, he is also in sale. He is also in a sale.
Yes, yes, sir. You speak about anything about the sale at ISCO, Burnpur. What actually ISCO Burnpur is doing?
Sir, actually, I am working in Rourkela Steel Plant, sir. From the date of joining onwards, I have been posted at Rourkela Steel Plant, sir. But ISCO Burnpur is also similar plant like Rourkela Steel Plant. But as far as I know, it is the first plant, sir. Compared to all this, it has started more than 90 years back, sir. It is integrated steel plant, ISCO Burnpur.
What they are producing?
Producing ISCO Burnpur. Sorry, sir. I never went there and never got.
DRDO, which materials will be required? Will be requiring? Or suppose they want to construct a missile, what materials are used in missile?
Sir, they need steel, sir, special steels. And in our Rourkela steel plant, we produce maraging steel, sir, for producing armored vehicles.
Suppose the officer asks you the same question, from which which plant you can supply this steel, then you will be blank there.
We our Urkala steel plant supplies the Maraging steel, sir, for DRDO. Currently, we are supplying it.
ISCO is the oldest steel producing plant. What Durgapur is doing?
Durgapur also it's also an integrated steel plant, sir. There we produce wheels and axles, sir, for Indian Railways.
There is one plant I am forgetting nearby Durgapur. Which is that?
Bokaro, sir. Bokaro, Durgapur and Bonapur, all three will be like near.
Any other? Bhilai?
Bhilai is in Chhattisgarh, sir.
Okay. How do you define 1 kilocalorie in terms of kgf meter?
Sir, 1 kilocalories, 1 calorie is like it is a British standard of energy, sir. Like calorie, 1 calorie is like around 4.2 joules, sir.
I am asking in kgf meter, not joule. Calculate it. 1 kgf. What is 1 kgf meter in joules? What is 1 joule?
1 joule is like 1 Newton meter, sir.
1 Newton meter per second or only 1 Newton meter?
1 Newton meter, sir. It is a unit of energy.
Okay, Newton meter. Then 1 kgf is equal to how many kg meter per centimeter square? 1 kgf? What do you understand of 1 kgf?
Kg foot per meter, sir.
The force acting on 1 kg mass by gravitational acceleration, that is 9.81 kg meter per centimeter square. That is 1 kgf is equal to 9.81. Hello? 9.81 Newton. Okay. Multiplied both the sides, then 1 kgf meter is equal to 9.81 joule. For a thermal engineer, conversion of units is the essential part. Okay. How do you define the battery, the voltage of battery? Suppose you are asked to procure a battery, 12-volt battery. What is specification you will give?
Sir, I need the ampere, the current I need to get from the battery, sir. Like the output voltage and the ampere and what is how much watts we can store in the battery, like watt hour.
Nay, have you used any battery anywhere in your car or at the Steel Authority of India Limited?
Yes, sir.
So, how do you define the capacity of the battery?
Like it's like in kilowatt hours. Like I mean, how much energy we can store in it, and then what is the output voltage, output current?
That is in ampere hours. How much
Yes,
ampere it can deliver in an hour? Okay. Generally, 160 to 200 AH batteries are being used of 12 volt. What are fundamental units?
Fundamental units are the building blocks of the derived units, sir. Fundamental units for like we can construct any kind of unit with the help of fundamental unit like meter, kg, and then time in the length, mass, and time domains. Fundamental units.
See, when the question is very simple, then the answer should be very, very precisely and accurately given. There are 7 fundamental units. Tell them. This is mass, kg.
Sir, mass.
Symbol is this.
Sir, mass in kg, sir, and then length in meter, sir, and then
Okay.
time in seconds, sir, and then current in amperes, and then intensity in candela.
Okay.
Yes, sir.
One is missing, which is related to thermal engineering only.
Temperature, sir, in we measure it in Kelvin.
Another is missing, which is related to thermal engineering.
It's energy, sir, joules. Is
No,
it
no,
not?
energy
Joule
is
is a
right.
derived quantity.
The amount of substance that is in mole. Mole is also a fundamental unit.
Acha. Quantity, okay, sir.
Okay.
Okay, sir.
So you don't expect that only tough questions will be asked.
Okay, sir.
Okay.
Okay,
Can you make a graph between velocity and the time of a projectile? Suppose आपने एक मिसाइल छोड़ दिया, अब आप देखो इसको, ओके, उसका ग्राफ बनाओ U and T में.
Okay, sir. Velocity versus
और एरिया शो करो, ठीक है, जो डिस्टेंस ट्रेवल्ड जो है उसको शेडेड लाइन से ग्राफ में रिप्रेजेंट करो. प्लीज रिप्रेजेंट द डिस्टेंस ट्रेवल्ड बाय ए शेडेड.
yes, sir. Yes, sir. Sir,
यार ये सुनो, डियर हेलो,
sir.
S इक्वल टू UT प्लस हाफ AT स्क्वायर का तो बनाइए जरा. S इक्वल टू UT प्लस हाफ AT स्क्वायर. U is
sir.
the initial velocity, A is the acceleration. Then this type of plot this graph on graph.
Sir,
Velocity
you
and
told, yes, sir, but you told graph between velocity and time.
हाँ, velocity and time का ही तो बोल रहा हूँ ना. Velocity क्या है? Suppose initial velocity is U and there is
अच्छा.
acceleration A. So then V is equal to U plus AT. तो simple straight line आएगा. S is equal to UT plus half AT square का ग्राफ बनाइए.
Okay, sir. Sir, one small doubt, sir. Do I need to plot graph between velocity and time or displacement and time, sir?
मैंने velocity and time का बोल रहा हूँ आपको. यार ये तो 9th का क्वेश्चन है.
Sir, okay, sir, but projectile means
So now you see T is equal to 0, the velocity is U. Define
yes,
करिए. After at a time T, it is U plus AT. करिए इसको तो T पर at T, U plus AT और velocity, suppose final velocity is V. तो जब when acceleration positive, it will be going up. और if velocity कम है, then तो projectile के नीचे जमीन में हो जाएगा.
yes, sir.
T is equal to, मान लो T is equal to capital T, then velocity is V. दो पॉइंट को ज्वाइन कर दीजिए. So the where is acceleration? T is equal to 0, velocity is U. T is
Yes,
equal
sir.
to T, velocity is V. You cannot make a graph.
The highest point will be like V plus U, V equal to U plus AT, and then
ठीक है, up to T only ना, suppose ठीक है, okay, this is good, है ना, after time. Now at upper point when the top में है ना, the distance traveled कितना होगा, correct है.
distance travel will be like
आप इसको A को negative कैसे कर दिया?
sir.
When acceleration is always positive, तो ग्राफ को डाउन क्यों कर दिया?
But the direction is
ये gravitational उसमें कर दिया G में.
yes, sir.
When I am giving external force and always the acceleration is positive, how the velocity will start decreasing?
Because sir, initially we have thrown the projectile upwards, sir. At that time, the initial velocity is upside, sir, but the gravity force is downside.
Okay, that is a case of gravitational, but I am not telling you the gravitational projection.
But in a projectile, gravity will act, na, sir.
Okay. You are taking a case of gravitational, that G उसमें हो जाएगा. But if I say the acceleration is constant, उसी point तक का ग्राफ आपको बनाना है, ठीक है?
अच्छा, okay, sir.
You try to understand. This is a gravitational profile that after reaching velocity, you at that V is equal to 0, U is equal to GT, है ना? Then again, but when acceleration, then U plus half AT square will be the area.
Yes, sir.
That is distance. देखो यार simple चीज है. आपको A बार मैं A बोल रहा हूँ. I am not using the word gravitational G. ना?
Okay, sir.
Okay.
Okay,
तो assumptions अपनी तरफ से मत करो.
okay, sir. Okay.
ठीक है. अच्छा. You tell me about the Rankine cycle and turbine function.
Okay, sir. Sir, Rankine cycle, we predominantly use it in a power plant, sir. There we use like 4 important processes are there, like isenthalpic compression in isenthalpic pressure increase in pump, sir. Then constant pressure heat addition in boiler, sir. Then isenthalpic expansion in turbine, sir. Then again constant pressure heat rejection in condenser.
Suppose at the exit of turbine, the water vapors are very high. What you will do, and what effect it will give to turbine blades?
Sir, it will damage the turbine blades, sir. That's why we cannot while expansion in turbine, we should ensure that the air water bubbles would not damage the turbine, sir. Like that, we will till that point we will expand in turbine, sir. Then after we will send it to
what remedies will you recommend for such situations to improve? Reheat factor and bleeding of why it is done, certain amount is
we use reheating to increase the quality of the steam at the turbine exits.
Okay, that is the thing, na? That answer is required. Okay, make a simple diagram so that I can understand that you are putting the arrow at the proper place. Make a turbine, make a condenser, make a pump, make a boiler, and the line diagram showing this.
Okay, sir. Sir, this is the Rankine cycle, sir.
Yeah,
Here
I am telling you to make the symbol of turbine. The symbol of turbine. and I want to see that the entry of a stream you are showing at a point and exit at a point is correct.
Oh, okay. Sir, this is the turbine, sir.
थोड़ा बड़ा बना यार, मेरे को भी नहीं दिख रहा है.
Sir.
हाँ, ठीक है. Okay. But it is vertical. ये ऐसे actually नहीं दिखाते, इसको vertical दिखाते हैं, समझे ना?
Okay, sir.
Vertical. Condenser. How do you symbolize the condenser? इसके
Yes, sir.
exit के पीछे और condenser बताओ, उसको symbolically show करो.
Okay, sir.
बहुत time ले रहे हो. You're taking much time.
No, sir. So condenser is basically a heat exchanger, sir. This is the inlet of the coolant water, sir, and this is the inlet of the hot steam, sir.
ये ठीक है, लेकिन इसको क्या करते हैं, एक लाइन में ही only a circular is indicated, and then in between a line from horizontal is coming like a coil, उसको बाहर दिखा दिया. Then the cooling water and outgoing water heat rejected. वैसे करके दिखाना. It is at the time of designing the condenser. It is not the symbol used in the Rankine cycle. It is not the use. It is not the pump test. In that case, only suppose exit say you take arrow, make a circle. Okay, in this circle, outside say one water line is coming, and वो 2 round देने के बाद में it is going out, and condenser rotate, and heat out is projected. Heat को बाहर arrow की तरफ से दिखा दिया, like this. Okay, pump. How pump is done? Pump is again a circular वो.
Yes, sir.
Because you should not only speak, your paper should speak.
Sir, this is the pump, sir.
Okay, देख लेना, any thermal engineering के बुक के ऊपर ही ये लगा होगा डायग्राम, ठीक है? इसको जरा देख लेना, and that diagram should only be represented, ठीक है?
Okay, sir.
Thermal engineering में what is special thing you have studied?
Sir, my M.Tech project is on like optimizing the heat sink for a concentrated photovoltaic module for different flux conditions.
For different
Heat flux conditions.
Heat flux condition.
Yes, sir.
Okay. What do you understand by flux?
Sir, flux is the energy radiation per unit areas.
How the intensity of light is measured?
The intensity of light is measured using pyranometers.
With
Pyranometer, sir.
Pyranometer?
Yes, sir.
अरे यार, लक्स मीटर होता है वो.
Sir.
लक्स मीटर होता है, लक्स मीटर.
Oh, but we use pyranometers also, sir. We use pyrometers for measuring temperature, sir. We use pyranometers for measuring the radiance.
Okay, I may not be aware. What is the unit of mole heat capacity?
Mole heat capacity, sir.
Joule per mole per degree Kelvin.
Achha. Okay, sir.
The dynamic viscosity ka what is the unit?
Sir, it is Pascal second, sir. Newton second per meter square, sir, for dynamic viscosity.
Heat flux density. Iska kya unit hai? What is the unit?
Sir, it's watt per meter cube, sir.
What?
Watt per meter cube, sir.
Watt per meter?
Cube, sir. Density. Watt per meter cube. Heat flux density.
No, heat flux density is radians watt per square meter. That is in kg per second also. It is watt per meter square.
That is heat flux, no, sir. Density. You asked density.
Heat flux density, it is written, and it is watt per meter square. ये correction देख लेना इसको, ठीक है?
Okay, sir.
नहीं.
Okay, sir.
Surface tension का क्या होता है? What is the unit of surface tension?
Sir, it is the Newton meter, sir. Surface.
Heat transfer में जो Stephen voltage law है, what that speaks of?
Sir, Stephen Boltzmann law basically tells us the gives us the relation between the energy emitted by a body and the temperature of the surface, sir. It states that the energy emitted is directly proportional to temperature to the power 4.
Very good, very good. What is sigma? The value of sigma and the unit of sigma?
Yes, sir. It is a Boltzmann constant, sir. The value is 5.67 into 10 power minus 6.
For specific heat for air, CV कितना रहता है in terms of SI units?
0.718 kilojoule per kg Kelvin.
0.71128 kg. Okay. Your knowledge is good, यार. Your degree of confidence is also good. ठीक है? और simple questions में मत अटक जाना.
Okay, sir.
ठीक है? Simple questions को patientfully समझ के units को answer देना. ठीक है?
Okay,
Very good, very good. Okay.
Thank you, sir.
Wish you all the best. सुनो, secondly, जो steel के बारे में जरूर पढ़ लेना. From ore, how the steel is done from ore to cupola furnace.
We use blast furnace.
हाँ, और आपकी यूनिट्स स्टील की जो सेल की कहाँ प्रोडक्शन कर रही हैं, जो प्लेट्स कोल्ड वर्किंग कहाँ हो रहा है, कहाँ से प्लेट्स जा रही हैं, ओके, कहाँ से क्या क्या व्हाट सप्लाई, कहाँ से फोर्जिंग जा रही है, ये सब पता कर लेना. ओके, देन यू विल बी क्लियर. ओके,
Thank you, sir.
थैंक यू.
Thanks.